I downloaded the Android Studio to try and make my first
All right, happy Friday, everybody. Welcome to class. So today we are going to, I spelled circularly wrong, but what was that? I don't know. Always good to double check. No, it's all good. So today we're going to learn about some things that, I think we were all already kind of thinking about doubly linked lists because we've had some questions about what about if we could go add a link backwards to a previous node, and we'll also talk about circularly linked lists. So, got a typo here, but for circularly linked lists, so the motivation here is that sometimes when we have a list, really, it has an order, but it doesn't really have a start and an end. Like, if you think about if you have the order of players in a game, you just keep going, It's not like you stop after you get to the end, you keep going. And so there are actually a lot of applications where we might want to have a circular list. And the one that we're going to go with, because we've already been having our linked lists hold strings for airport codes, is suppose that I'm a pilot and I always just fly Bozeman to Minneapolis to Seattle to Bozeman to Minneapolis. I just fly in a circle, and I want to be able to have a list that tells me my next 3 airports that I need, my next 3 flights. So if I'm currently in Bozeman, then my next flights are Minneapolis, then Seattle, then Bozeman. But if I'm in Seattle, then my flights are Bozeman to Minneapolis to Seattle. And so what we'd really like to have, where's my mouse? What? Somehow, wow, okay. I did not know. Somehow my iPad, my cursor can go over to my iPad, which I did not anticipate. So anyway, here we have a representation of our that situation, right? MSP follows Bozeman, Seattle follows MSP, and I want a method, rotate, that is going to allow me to just rotate so that, say, SEA is at the front of the list. But if you think about it, what would I need to do that? So I want my new list to be, so I'm currently BZN, MSP, SEA, and I want to turn this into, so I already did Bozeman, so it would become last, so I want to turn this into MSP, SEA, BZN. But in order to do this, so what would I want to do? Let's see. I'd want to take my, whatever's in my front, and put it in the back. And I suppose we actually do have a remove first and an add last method in our current linked list. But if we think about it, if instead of having our same old linked list, actually we can keep that. If instead of having my final pointer point to null, in order to make this circular, what can I do? I can just have my final pointer just point right back to the beginning. And so now all I need to do is, I really don't even need to maintain both head and tail, right? I don't know why this is still here. I'd like it to go away. I don't even really need to maintain head and tail, because if like if Bozeman is currently my front, I can get there either through head or through tail.next. And so the way that we do this is we actually don't even keep head around. We get rid of head, and we just maintain tail. And so if I want the front, what is that? It's just tail.getNext. And if I want to do rotate, like what do I have to do to rotate? I only have to do one thing, right? Can anybody tell me what I'm going to need to do? Yeah. Yeah, I mean, if, let's say I define tail is the end of the list. And so if I want to, I'm just going to keep tail to represent the end of the list, yeah. Exactly. All I got to do is move tail to whatever tail.next was, and now Bozeman is the end of my list, just like I want it to be. And so that is sort of the glory of the circularly linked list, is that we no longer need a head and a tail, because head was always just tail.getNext, right? Great. So let's look at some Java code and see how we would change our linked list implementation that we already have to a circularly linked list. So what I'm going to do is I'm actually just going to copy over the code from day 19, so what we ended with last time. And I'm going to copy both the singly linked list.java and the demo code that we had. I already have a day 21 package, and I'm just going to paste this in so that I have these two files. And then in Eclipse, I'm going to use the refactor and rename option to refactor this to a circularly linked list. Circularly linked list. And then, okay, I'm going to open this up. So thanks to Eclipse, I have already replaced anywhere that it said singly linked list. I now have circularly linked list, including in my demo. So before we were creating a singly linked list, but now we are making a circularly linked list. So let's hop over here and see what we need to change. So we're going to keep our node class exactly the same. But first off, okay, I already said we're going to delete head. So let's do that. Our constructor, we can stick with an implicitly defined constructor that's just going to set size, and well, size will be set to 0. Tail will be set to null automatically. And I actually wanted to, okay, so we have some methods here that we're going to need to change. But the ones that I want to get to in class today are, I want us to write that rotate method that we just talked about. We're going to write rotate. We're going to write first. We're going to write add first. Add first. Well, we'll see if we get to all these, but the goal would be to do all of these and toString. Because I also want to talk about doubly linked lists. Although, yeah. I did. Yeah. So we deleted, we no longer going to keep track of head because, and we can just write a note here, note, head can be accessed as tail.getNext. So that's why we deleted head. Yeah, so we're also going to talk about doubly linked lists today, although your lab for next week, you're going to be implementing some new doubly linked list methods, so we're not going to go as deep on that because you're going to get the opportunity to actually write some methods for that. But, okay, these are our goals. So let's start out with this rotate method. So public void rotate. We're not going to take anything in anything because our goal is just to update the list by sort of pushing what was at the front to the back, in a way. And we already said that all we need to do is we need to set tail equal to tail.getNext. So going back to our picture, that's what we did here. Tail was pointing to SEA, but because SEA, this node now has a pointer to the front, I can just change my change what the back is just by following that. And so now when I do, suppose I want to get the first node, it's going to be tail.getNext, and that's just going to be MSP. But we still have this like corner case where what happens if our list is empty? So what if list is empty? Well, the issue we would run into is we would be trying to call getNext on null, and Java would not like that. So we want to protect ourselves from that. So we're going to say if size is not 0, then we should do this. And otherwise, we actually don't need to do anything, because what does it mean to rotate an empty list? Well, we don't have to do anything. Yeah.
So if we only have one element, are we going to define it where its next value itself?
Yeah. That's a great point. Yeah, we didn't draw it, but what would happen if we had only one? Well, it would be, I'll give it some space. This, PDX, say, is the only thing in my list. Well, it just points right back to itself. And again, totally reasonable. We can do that. So that would be a single element circularly linked list. Cool. Let's now look at our next method. We also want to do first. So first is going to return us our first element. So because our elements are strings, we're going to return a string. And we don't need to take anything because we're just returning the first element. So we've said this already actually, so we'll just put it in here. So what we want to do is to return the first element, that's just tail.getNext, except our user who's interacting with our list, they don't want to get nodes back. They want to actually get the string that the node holds. So we're also going to call getElement. And then again, we would have the same issue if this was empty, that we would be trying to call these methods on null, which we don't want to do. So I'm going to say if size is 0, then I should do something. I think I should just return null, maybe? Yeah, that seems reasonable. So if there's no first element, then what we return is null. Otherwise, we return whatever is in tail.getNext. So in our current situation, where is tail? Tail is BZN. So tail.getNext.getElement would return us this nice string right there. Okay. We got first. Okay, so now, I've got some other methods down here that I'm just going to delete because we're not going to implement them today. So, and we still got issues because we've got some methods that have head in them, but we're going to fix that. All right. Let's work on add first. So add first. Okay, we no longer, so we want to add first, add to the front. So we no longer have a head, but we do have, instead of head, we have tail dot, let's see, let's look at our picture. Oh, aha, here we are. Okay, so add first, let's say our tail, let's say our tail's still pointing to SEA. So our list is actually BZN, MSP, SEA. So just like we have seen before, to add first, we're going to need to make a new node, and then we need to hook it up. So if I want to add first, I want to add it before BZN, right? Well, that's easy enough. If I want to add this in before BZN, then it just needs to point to BZN, and my tail just needs to point to it, right? And so once I've done that, then I would have SLC, BZN, MSP, SEA. So that's all we need to do. So how are we going to do that? Okay, let's maybe think about how we want to do this. So we want to make this new node, right? And let's call it newest. And what is newest? It's a new node. And what's its data? So this is the one we're adding in, right? What was that?
SLC.
Yeah, in this case it would be SLC. And what's the variable name that we're passing in that corresponds to that? Yeah, exactly. Element. And then what do we want to hook this one up to? Yeah, exactly. So what we think of as head, but we don't have head anymore, we just have tail dot get next. So after we've run, like this line of code corresponds to making this node, making this SLC node, and hooking it up to point to whatever tail dot get next was, which was BZN. Well, actually, at this point, so we haven't changed anything about tail. So after running that line of code, we would actually have this situation, right? Tail is still pointing to BZN, but our newest node, so this is newest, is pointing right there. So that's the situation we have at this point. So what do we have to do next? Yeah. So I need tail to point to whatever newest points to, which is that node right there. So tail dot set next, right? Is newest. Yep. Great. And then we still have this boundary condition where if the list was empty, then we would be calling these methods on null, which we can't do. So what should we do in that case? Well, let's imagine we had an empty list. So we're adding something. So tail needs to point to that thing. And so tail needs to point to this. We need to create that node and point tail to it. So how do we do that? New node. And it's got the element that we passed in. And we can start it out pointing to null. But then we said, okay, what's a we deleted it. But a single element circularly linked list, it's got to point back to itself. So we also would need to set tail.setNext to tail. So then we'd have this nice single element circularly linked list. Yeah. Great. Any questions or comments so far? Thoughts? Yeah.
You still have to increment the size of like the element list.
Thank you. I had totally forgotten about that. Oh, no. Okay. Yes, we do need to increment the size. But, yeah, thought I'd forgotten about it. But rotate and first don't add anything. So we were fine there. But, indeed, thank you for reminding me, because I definitely would have forgotten. We do need to increment size. So, yeah, size plus plus. And we do that, I guess we should have an else here, huh? Yeah, so we do one thing if it's empty, we do a different thing if it's not empty, but no matter what, we increment the size. Okay, so we got add first. Now let's think about add last. So add a string to the end of the list. All right, let's look back at our picture. Okay, so we got our list that goes SLC, BZN, MSP, SEA, and we want to add PDX to it. So we got PDX. So same as, and we want to add, so we want to add PDX at the end. And so in a way, it's kind of like, oh, we basically do the same thing, right? Like we still, so when we added first, we still added this node between our, we add after our tail when we add first. And if you think about it, we're also going to add after our tail when we add last, right? Because I want to stick this right in here. I want PDX to point to SLC. I want SEA to point to PDX. And then what would the last thing that I need to do be? Yeah, I think I heard switch tail. So indeed, I just need to move tail up. And so if you think about it, we actually do exactly the same thing in add last as we did in add first. And so, yeah, actually, let's before we even go to our code, so let's say that let's say I forgot to update my tail and it's still pointing to SEA. What have I actually done in that case? What was that? Yeah, I've actually added first. So what I can do in order to implement this is, instead of writing a whole bunch of new code, I can just call my add first method with element, And then I can move my tail. Oh. Yeah, you're saying could we just call rotate instead? Yeah, wait, okay, let me think. So I mean, that sounds right to me. So before, okay, let's go back to our picture because this is basically what I have to do every time. So before we moved tail, I mean, yeah, but I think you're exactly right. So we got PDX, and then we move tail so that it points to PDX, which puts PDX at the end. And that does feel exactly like what rotate does. We can even check our, so, I mean, I think we could. So in the book, they do tail equals tail dot get next, but I feel like we could do rotate. Oh, and this was left over from previous. So, I need a semicolon. Okay. All right. What was that? Add first. Yeah, thank you. Great. Let's see, our time. Okay, I think we're good on time. So let's also update our toString method. So I think, no, I don't have any pictures for toString. So for toString, I think that, or what I was thinking for our circularly linked list is that, so, oh, hey, actually, I hadn't looked at what we actually had in here. Because I was thinking of the book's version, which is different from what we ended on. So what we ended on last time and what I have in here, we first grab whatever's in front. So maybe let's just change this to, instead of head, that would be just tail dot get next. And so we start with whatever's in the front, so that's our goal. Our goal, print the elements in order, right? So we want to start with the first one. So we've got tail dot get next. Oh, and here we just add one more. So this almost feels like it could work as written. Let's save it. Well, we can always try it out, and easy in. Looking like it's like our implementation from last time actually might carry over to a circularly linked list. So that's nice. Let's try. Okay, so now, over to our demo code. We tried add first. Looks like that works. It put something in. Add last. Looks like we put MSP. We called add last on SEA. Looks like that worked. Let's try rotate. Our list dot rotate, and then let's print it out. And that's looking good to me too. Cool. So yeah, we got a pretty good circularly linked list implementation going. Yeah, any questions on that before we move on to doubly linked lists? No? Okay, so yeah, let's go over to our doubly linked lists. So actually, so I finally got these slides Oh, I was supposed to delete that before we started. Let's do it. Select, cache, done. Okay. Finally got these slides from the our textbook, but I don't. It seems like they're copyrighted, so I'm not going to put them. I'm not going to put the PDF on the website. But it's kind of nice to have these pretty pictures from the book all made up. So doubly linked lists, great. So what's going on with the doubly linked list? We've got our nodes now. Instead of just having a next like we've seen before, our nodes now have both a next and a previous. And so this allows us to go forward and backward, very convenient. Of course, we've still got our element data. And then in addition to having a previous and a next, when we implement a doubly linked list, we're also going to have basically a dummy node at the front that we're going to call header, and a dummy node at the back that we're going to call trailer. And what the header and the trailer allow us to do is, instead of, like we've done, so all of our linked lists that we've built so far, we've had to deal with these special cases where we're like, if size is 0, then we have to do one thing, but if our list already has stuff in it, then we're going to do another thing. But by having this header and trailer dummy nodes that are empty, we can treat all cases the same. And so this allows us to reuse code and reuse logic. And so as a person who studies algorithms, I find this very much nicer, because instead of always having to say, okay, if size is 0, do this thing, otherwise do this thing, it's just, oh, you're adding a node, you want to add a node somewhere, just call your add node method. This logic that you have, that we've perfected, the logic to add a node, and now we can just use it every time we want to add a node. We don't have to think about any special cases. So that's very nice. Additionally, just as a reminder, usually we're going to want these to be, our nodes are going to hold as their data, they're going to hold generic, something generic. So maybe we've been working with strings, implementing our linked lists with strings in class, but in your projects and in your labs, you're implementing your linked lists with generic types. So really, what do these nodes hold? They're actually holding a pointer to an object. So these objects are, nice animals, I guess. Yeah. So let's think about inserting a new node in a doubly linked list. Well, it's a lot like inserting nodes into our other linked lists, except we just have to deal with pointers in both directions. So we want to insert node Q between P and whatever comes after it. So we want to put it in right here. Well, and our node is called Q. Well, what do? We just need to first hook up Q's previous pointer to P, and hook up Q's next pointer to whatever P pointed to. And then we also need to fix, so P was pointing to C, right? So P was pointing, let's erase some stuff. P was pointing to its original next, but it needs to change that pointer to point to Q. And whatever was after P was pointing to, its previous was pointing to P, so we're going to have to hook that up to Q. But really, the logic is basically the same as what we've seen already. Cool. Any questions about that? Just looking at the picture, yeah.
Did you run your job or build one?
I think I did. You mean from what you downloaded from the webpage? Or just following along? Yeah, I mean, I think I'm running it because, like, I added rotate, and I could add, like, our list dot add first. Let's do PDX. And then let's print it out. It's definitely worth checking this, but yeah, it looks like my demo's working. It's possible. Yeah, we can take a look at yours after class. So, any questions about inserting a node? Yeah, really just about changing pointers, right? Same as we've been seeing. So, just to think about this a little bit, and make sure that we understand this header and trailer nodes. Let's say we want to initialize a new doubly linked list. So what does the doubly linked list constructor do? Can anyone tell me, like, what will we have after we call the doubly linked list constructor? How many nodes are we going to have? So that makes sense. In our, we could have 0 nodes. We kind of think we have 0, like, we're storing 0 data, but we have this header and trailer node. So in fact, to start off, we have to have 2 nodes. We have these empty nodes that are dummies that allow us to treat even an empty doubly linked list with the same logic that we treat a doubly linked list that has multiple elements. Yeah. So we got 2 nodes. All right. And how many, like, fields does each node have? It has 1. It has 2 plus 1 because it's got it's got a next. It's got a, oh gosh, that was silly. It's got a previous, it's got a next, and it's got some data. So same with this one. And so this first one is our header. Actually, I'm going to put this. It doesn't really matter where these arrows that point to it point, because they're just saying that we have a variable that allows us to access this data. So I can really point these arrows wherever I want. And we have trailer. And these are actual dummy nodes. They're never going to hold anything in here. In fact, I could write null. Header and trailer are always just going to have null. And so where is my header dot next pointing when I'm just initializing an empty list? Yeah, to trailer. So yeah, our doubly linked lists don't need to be there. This one at least is not going to be circular. So header, when we started off, is just going to point to trailer. And what about trailers previous? Yeah, it's just going to point back to header. And so, to be clear, this isn't, and then these are just pointing to null, but we're not really going to actually talk about that. Like, we don't ever set them to null. And we don't actually have to think about what they point to, because we're never going to actually try to traverse to the left of header or to the right of trailer. We're just going to stop when we get to header and trailer. But they would, in fact, be pointing to null. But you'll notice like the book just represents them, just ignores the previous for header. So this would be header, and this would be trailer. And the book doesn't even think about the previous for header, which is reasonable. Yeah. So this is actually what needs to happen when we construct our doubly linked lists. Additionally, what was I going to say? Oh yeah. So it's not actually anything special about doubly linked lists that forces us to have a header and a trailer node. It's just that it allows us to write cleaner code, and really, like, as we saw, the Java linked list class is actually implemented as a doubly linked list. So it's starting to include some optimizations that allow us to write clean code that we would use in real software. So let's look at this code in Java. Back still in my day 21, I'm going to make a new class, and I'm just going to copy down the doubly linked list code. That this is actually exactly the same. Like, I'm actually just linking to the code that you have for the lab, because this is just the books doubly linked list, and I'm pasting this in. I'm going to need to change this to day 21. And okay, so let's just make some observations based on what we just saw. So yep, we got a previous. Our node class now has a previous and a next, not just a next. And just like we would expect, we got methods to set those, get those, etc. And we now, instead of pointing to just having a point to our head node, point to a trail node, we just have links into our header and our trailer. So these are our doubly linked list fields. And now let's look at the constructor. So does this match what we just said? Well, okay, we made header, which was a new node. At first we made it have nothing. We made trailer, and what is this second argument here? That is set trailers prev to header, right? Like, let's look at my node. If I want to even double check that, I could look at my node constructor and I see, yep, the second argument to my node constructor is setting prev for the previous node. So yep, that's exactly what we did. And then we set headers next to trailer. So yep, looks like the code here matches what we did in our constructor. Now, the last thing I want to point out, and I really want you to, yeah. Oh, like here? Yeah, honestly, okay, wait, this dot header, wait. Sorry, I thought I knew what you were saying, and then I realized that I didn't. Yeah. Yeah. Okay, so instead we would change because like we could just do this dot trailer here. Oh yeah. Yeah. I see what you mean. And this dot trailer. Yeah, honestly, seems to me that you are right. Let's look at I'm just looking at, so these are the slides that have the this is the book's yeah.
So for this trailer, you usually do those correct on the second one. If you do the above, it will not have
Oh yeah.
But then we have a reference.
You'd be setting it to null
Okay.
instead of, what was that?
Could be like 2 lines if instead of like this dot header, new node, null, null, new node, null, this dot header, null. Like create a node for the location of the next point. And then this line, this dot header dot next to this dot header. So it just wouldn't be
Yeah, like, are you saying,
just copy and paste how you do it for
well, let's look at, there's one last thing I want to point out, but yeah, before we end class. So, and that is, okay, so we still got our same methods that we've been working with, adding first, adding last, etc. But you'll notice that this code comes with some helper methods, such as this private add between, and also this public remove method, which I actually don't know why this is public. I'm kind of surprised that the book would even have that as public. Oh, it is? Okay. So the book has this as private, and I also think this should be private because we don't really want to be exposing the user to nodes. Like, the user should never know about nodes. So this should have been private. That was just a mistake. But remove and add between are both private, and they contain the logic to execute adding in a node and deleting a node. And because we have header and trailer, we can use the same logic no matter what. So let's, if you notice, like, our public remove first method now just returns, I guess there is some extra logic here, but it just calls this remove method. And what else? Let's see. Remove last also just calls the remove method. Similarly, let's see if we see where add between is called. Yeah, similarly, add first and add last just call add between, but with different arguments. And so now we can really start reusing code because we have header and trailer. So, looks like we're almost at time, and we got a nice intro to doubly linked lists, which we will use next week. Have a good weekend. Come up and ask questions if you have them. See you on Monday.
This should hopefully